Alright, let's look at the homework 4.2, problem number 6. Alright, so we want to sketch the graph of f of x is equal to 3x times quantity x minus 2 cubed. Alright, so let's do that. Alright, first question, we want to find its domain. Right, so domain, but this is just a polynomial function. Domain is all real numbers, so it's a negative infinity to positive infinity. Alright, so let's check the answer. Alright, we got that. Alright, so we want to find the Y-intercept. So in order to find Y-intercept, you just need to plug in x equals 0. That's actually, we can do it in our head. If you plug in 0 for x, that's 0. So Y-intercept is actually 0. Alright, we got that. Alright, so we want to find the X intercepts. So we set the function equal to 0. It's already factored out, so we can see that the x equals 0 and x equals 2 would be the X intercept 0 and 2. Alright, let's check the answer. We got that. Alright, then what is the local maxima? And let's see, it's the local max. So we want to find the local max, so we have to find the critical number. Alright, so let's do that. Alright, first we need to find the derivative. Alright, 3 is just a constant, so we put it here. Then we use the product rule to take the derivative. So that's the first guy, that's the second guy. Alright, so the derivative is going to be derivative of x is 1 times the second, so quantity x minus 2 cubed plus first guy x times derivative of that is 3 quantity x minus 2, subtract 1 from the power, multiply by derivative inside, which is 1, so that's going to be it. Alright, so we need to simplify this. I'm going to pull out. Alright, so quantity x minus 2 squared, and there are actually 3 of these, so I'll just circle that, and I'm going to pull those out. So 3 is already out. Then we have x minus 2 squared. Right? Then what's left is, let's see, another x minus 2 from here. So we took care of that. And then we have 3x. So plus 3x. Right? So that would be, so this is 4x minus 2. So I'm going to pull out the 2. So it's going to be 2 times 3 is 6. Pull out the 2. X minus 2 squared. And the 2 is pulled out. 2x minus 1. Right? So critical numbers would be, so set that equal to 0. So we can see that x equals 2 from here. And x equals 1/2. Right? Then we want to see if it's a local max or local min. So we're going to do a number line. Alright, so it's a 1/2 is right here. And the 2 is there, and we are interested in the first derivative, f prime. Right? Let's try some simple number. Anything smaller than 1/2, so I like 0. Anything between 1/2 and 2, so I like 1. Anything bigger than 2, so I'll try 3. Right? So let's look at this. Right? So here 6, and there's a square here. This is always positive. So we just have to look at this. Right? If you put 0, 0 minus 1 is negative, so that's going to be negative. Right? If you put 1, 2 minus 1 is positive, so that's going to be positive there. And if you put 3, 6 minus 1 is positive, so that's going to be positive there. Right? So original function is actually decreasing there, and increasing there, and increasing there. So you can see that you're going to have here local minimum, and there's no local maximum. So let's do that. So there's no local maximum. Right, we got that. And a local minimum, and it's going to happen at let's see, 1/2. Right, then check that. So we got that. And what are the inflection points? All right, so we have to, in order to talk about inflection points, we have to take another derivative. Right, so let's take the derivative of this guy. So f double prime of x is equal to, right, 6 is just a number, put it here. Right, derivative of the first guy is 2 times x minus 2, and times the second, 2x minus 1, plus first guy is quantity x minus 2 squared, times derivative of the second guy is 2. Right, so let's simplify that, and let's see, so we need to pull out what's in common. It's 2 here and 2 there, we can pull that out. And x minus 2, and there are 2 of those, x minus 2. So 2 times 6 is 12, and the x minus 2 is pulled out. Right, so what's left is 2x minus 1. Right, and what else? You're going to have another x minus 2. So plus x minus 2. Right, so that will give us, so this is going to give us 3x minus 3. So you can pull 3 out. So if you pull 3 out, 3 times 12 is 36, and x minus 2. And if you pull 3 out, so x minus 1. Right, so if you set that equal to 0, we get x equals 1 and x equals 2. Right, so we're going to do the number line again. So here, this time we're interested in the second derivative. So f double prime. Right, so let's look at the sign. Anything smaller than 1, so I'll try 0. Between 1 and 2, so I'll try 1.5. And anything bigger than 2, I'll try 3. Right? So we just need to look at the sign. So if you put 0 here, 0 here, negative 2 times negative 1 positive, so you get positive sign here. Let's see. Positive sign there. Right, and here 1.5, so that's going to be negative, that's going to be positive, so it's going to be negative. 3, positive, positive, so everyone's positive. Right, so you can see that you're going to have an inflection point because the concavity is changing. So you have an inflection point here and also inflection point there. So it's at 1 and at 2. Right, so it's going to be at 1 and 2. Right, check the answer. We got that. Alright, on what interval f is increasing or decreasing? Right, so let's go back and look at this. Alright, so it's decreasing on the interval from negative infinity to 1/2. After that, it's increasing. Right, so increasing on. Alright, let's see. 1/2 to positive infinity, and decreasing on negative infinity to 1/2. Alright, so let's check the answer. We got that. Alright, then let's see, we're concave upward and downward. If you look, right, you have concave down, so f is, right, concave up on this interval, and a concave down on this interval, and concave up. Right, so if you want the concave down upward on the interval negative infinity to 1, and also 2 to positive infinity, and a concave down on in between 1 and 2. Right, so let's do that. Got that. Alright, so we want to see if we have the right picture. So let's see, up to 1/2 it's decreasing, after that increasing. This is promising. This is increasing, not right, and this is somewhat promising. This is not, so either between these two. Alright, let's look at the concavity. So concavity is, let's see, it's a concave upward on up to 1 and a 2 and up. So here, up to 1, and you can see the concavity a little stretches even more. How about this one? Concave up to 1, and concave up after 2, and concave down. So this has got to be it. Check the answer. We got that. Alright, that's it. I hope that this was clear.